looking here at the uniform distribution. Uniform distribution is where any outcome is exactly as likely as any other outcome within a particular range. The example I always see in textbooks is, suppose you show up to a bus stop where the bus comes every 20 minutes. Well, the amount of time you're going to have to wait, you have no idea. It might be 5 minutes, it might be 10, it might be 12, it might be 19, but it's evenly distributed, right? Uniformly distributed between 0 minutes, the bus might show up right after you, or 20 minutes, the bus might have just left and you have to wait a whole 20 minutes for the next bus. But every time in between is equally likely. And we have our probability density function here, which in this case would actually be just the horizontal line at 1/20, which is just 1 divided by the distance between these two numbers. We're not going to need to use that. We're not going to care about it, but if you're interested. So let's not talk about this because I don't like the numbers that are too simple, but that's an example of a normal distribution that shows up all the time in textbooks. Another one is, suppose you have a group of kids in school and their ages are going to be uniformly distributed between, let's look at an easy example here. Let's go for 8. Let's say 8 and 20. I don't know what kind of school this would be. Yeah, that'll make a better example than have a 0 there. So we go from whatever grade this is to whatever grade that is. And if we talk about age in the sense of how many seconds you've been alive rather than how many years, right? Years would be discrete because there's gaps in between. But if we talk about how many seconds you've been alive, then there are a lot more possibilities along the way. And any one of them is equally as likely as the others. So it's a uniform distribution. What we want to talk about this time is how to find the mean of this distribution, the standard deviation of the distribution, and the range of likely outcomes, and we'll deal with probabilities in the next one. So the mean of this distribution, probably no surprise, mean is a measure of center, so it's going to be the number that's in the center of the distribution. It's going to be right here in the middle. And mathematically, the way you find that is just to average the two endpoints. So if this is A and this is B, right, uniformly distributed from A to B, one number to another, you just add them together, divide by 2, and we get what, 14? That's 6 away from each end. All there is to it, just averaging numbers. Not going to bother doing a second example of that. The standard deviation here is a funky looking little formula. It's just B minus A, which is how long the distribution is, how far the two ends are apart, divided by the square root of 12. And here, 20 minus 8 divided by the square root of 12 is going to be, I don't know, let me grab the calculator. I know that's 20 minus 8 is 12 divided by the square root of 12, and that's going to give me 3.46. Okay, that's the standard deviation. Subtract the two numbers, divide by the square root of 12, always the square root of 12. People sometimes ask where that comes from. It has nothing to do with the fact that this was 12 here. It has to do with, for the uniform distribution, it's always subtract those numbers, divide by the square root of 12. And then a range of likely outcomes is always the same. We start with the mean, and we subtract twice the standard deviation from it, and we add twice the standard deviation to it. So here, let's double our standard deviation, right? That'll give us 6.92. We would do 14 minus 6.92, and 14 plus 6.92. And this is always going to work out this way. This is going to be a little bit less than 8. So let's round it to the 8. And this is going to be a little bit more than 20. So let's round it to 20. Our range of likely outcomes here is just exactly the same as the entire distribution. If we're uniformly distributed between 8 and 20, and everything's equally likely, nothing's going to be unexpected, right? So our range of likely outcomes is just going to be everything, because everything is as likely as everything else. So you don't even have to calculate that. Just remember the range of likely outcomes is exactly this here. All right, next time we'll talk about how to find the probability that you're above, below, or between particular numbers. See you then.